Hi everyone, welcome again to your channel Maths Guide. In this lesson, we are going to explore one of the most fundamental concepts in mathematics, the highest common factor or HCF. The HCF is a key concept not just in school math, but also in real life scenarios like simplifying fractions, solving problems in ratios, and even in certain areas of science and engineering. We will break down the definition, walk through the few methods to calculate the HCF, and give you the tips on how to make the process easier. To explain this topic, I have referred the book of Mathematics 6. So let's get started. The term HCF stands for highest common factor, or in some places it is also known as greatest common divisor. Actually, HCF of two or more numbers is the greatest or highest number which divides all the given numbers. This definition will be clear to you when you will start solving the questions. There are two methods of finding HCF. One is prime factorization method and the other one is long division method. I have made a complete video on prime factorization. Link is provided in description. Using this concept, we can find HCF of any two or three numbers very easily. Now let's move on to exercise 1.3 question number 1 part 5 where we have to find out the HCF of three numbers, that is 14, 28 and 112. The first step is to resolve these numbers into its prime factors. Then we will find the common factors and the greatest among all the common factors will be HCF. According to this, the definition of HCF is that it's the product of common prime factors. So the prime factors of 14 are 2 into 7. And prime factorization of 28 is 2 into 2 into 7, and prime factorization of 112 is 2 into 2 into 2 into 2 into 7. The common among these factors are 2 and 7. The product of common factors is called HCF. So our HCF is 14. Now we will learn how to find HCF through long division method. There are three numbers, 65, 91 and 117. Make the greatest number the dividend and the smallest number the divisor. As you know, 65 into 1 is 65, the remainder will be 52. Here the remainder will become the divisor and the previous divisor will become dividend. Again we will divide 65 by 52. We get remainder 13. Again this remainder 13 will become next divisor and the previous divisor will become dividend. And 13 into 4 is 52 and the remainder is 0. This last divisor 13 will become HCF if we have only two numbers, 117 and 65. But there is another third number, that is 91. So this 13 will divide again 91 and the remainder will be 0. This 13 is now the final HCF. I hope you understood the sequence of how to find the HCF through long division method. Now you can easily solve question number 2 of exercise 1.3. Now this is exercise 1.3 question number 3, that is, what is HCF of any two prime numbers? The HCF of any two prime numbers is always 1. How? Let's see. Let's take two prime numbers 2 and 7. The factors of 2 are 1 and 2 and factors of 7 are 1 and 7. The common among them is 1. So HCF of prime number is always 1. Remember one thing, if the HCF of any two or more number is 1, then these numbers are called co-prime numbers. Here 2 and 7 are co-prime numbers. This is exercise 1.3 question number 4. Can the highest common factor of 8 and 64 be greater than 8? Explain your reasoning. Let's first find out the common factors of 8 and 64. The common factors of 8 are 1, 2, 4, 8 and common factors of 64 are 1, 2, 4, 8, 16, 8, 32 and 64. The common factors are 1, 2, 4 and 8. The highest among all these common factors is 8, so we can say the HCF is 8. You can also explain this concept through prime factorization method. Many math word problems require finding the HCF to solve. These might involve scenarios where you need to divide items evenly or determine the largest possible group size that fits all given quantities. For example, you have 36 pencils and 48 pens. What the largest number of identical gift bags you can make if each bag must contain both pencils and pens? For these kinds of questions, we can use HCF. This is number 1 real life example from your exercise 1.3, question number 5. Alize has 16 science books, 28 mathematics books and 30 English books. She wants to pack these books equally with no leftover. What is the greatest number of books she can put in each packet? Just keep in mind the number of books have to be distributed equally. For these kinds of questions, HCF will be helpful to find the greatest number of books she can put in each packet. So we have three numbers 16, 28 and 30. We can use either method of prime factorization or division method. I find this method easy, so I am using this. Make 28 as a dividend and 16 as divisor. We divide it, then remainder will be 12. This divisor will become dividend in the next step and the remainder will become divisor and we get 4 as a remainder. This 4 will become divisor and the previous divisor will become dividend and we get remainder 0. We have a third number 30 also. So we have this 30 as a dividend and the last divisor 4 will become the divisor of this number also. Then the remainder will be 2 and then this last your previous divisor 4 will become dividend and now it is completely divided and the remainder is 0. So the last divisor will become HCF. So our HCF is 2. So we can say that Alize can put 2 books in each packet. This next question is very similar to the previous question. This is question number 6 of exercise 1.3. There are 50 students of grade 6, 70 students of grade 7 and 80 students of grade 8 and teacher wants to arrange students in equal number in each row. Find the greatest number of students that could be arranged. Again, the teacher wants to arrange them into equal numbers, so HCF will be helpful. Finding the HCF, we got 10 is as the last divisor, which is the HCF. So we can say teacher can arrange 10 students in each row to divide them equally in each row. Now again a question from exercise 1.3. This is question number 7. Our room is 10 meter 15 centimeter long and 8 meter 80 centimeter wide. The floor is to be paved with square tiles. Find the length of the largest tile that can be used. Focus on the words that the length of the largest tile. So HCF can be helpful in this case also. If we want to cover this whole area with a square tile of any length, then how many square tiles will be required or what is the length of each square tile? This is actually the question. We have to find out the length of the square tile which will cover this rectangle. Now here is the solution of that question. If the length of that rectangle is 10 meter 15 centimeter, we will convert it into centimeter and we get 1015 centimeter and the width will be 880 centimeter. Our first step is to resolve them into its prime factors. 1015 and 880 has been resolved into the prime factors and next second step is to find out the common prime factors, that is 5. So we can say that the 5 is the common factor. So the length of the largest tile should be 5 centimeter to cover up that rectangle completely. Now it's your turn to recall the whole lecture again and answer all these questions. But first, subscribe to my channel if you haven't and click on the bell icon for timely notification of my videos. So let's try them now. HCF is a product of common prime factors. Another name of HCF is Greatest Common Divisor. HCF of co-prime numbers is always 1. There are 2 methods of finding HCF. Now give the answer of this question in comment section that which method of finding HCF do you feel is easy.